higher age are more likely to adopt for crop insurance and put more area under coverage. So we find that additional increase of 1 year of increase in age increases the probability of adoption by 0.5 percentage, as well as it increases the area under coverage by 0.009 hectares. Similarly, in case of education, we find that education also has a positive impact on adoption of crop insurance as well as area under coverage. So increase in 1 year of education increases the probability of adoption by 1.4% and increases the insurance coverage by 0.03 hectares. We also find that size of owned land, the land owned by farmers, increase in size of owned land by farmers increases the adoption of crop insurance as well as the area under insurance. In context of, we also find that credit is similar to area owned by farmer. Credit also has a positive impact on adoption of crop insurance as well as area under insurance. So we find that increase in credit by 1000 increases the probability of adoption by 0.3 percentage points and area under insurance by 0.01 hectare. Looking at the alternative risk management strategies such as livestock rearing and off-farm income and crop diversification, we find that they do not have a significant impact on adoption of crop insurance but has a negative effect on the area under coverage. So we find that farmers who are engaged in livestock rearing, conditional on adoption, they put less area under insurance, as well as farmers who have off-farm employment. It has no impact on their decision to adopt, but conditional adoption, it reduces their area under coverage. In context of socially lower groups such as SC and ST, we find that it has a negative relationship with adoption of crop insurance as well as area under coverage. And for the base category, we take other caste as base category, combining general and OBC. And compared to them, SC and ST both have lower rate of adoption as well as less area under coverage conditional on adoption. So from this, we conclude that crop insurance has an important role in mitigating farm risks, especially related to production risks. But adoption and coverage has remained low, and many efforts have been taken to increase the adoption, but the progress has not been much. So our analysis shows that age, education, and access to credit has a significant impact on adoption of crop insurance as well as area under insurance. On the other hand, off-farm income and livestock rearing, informal risk management strategies such as this too, does not have much effect on adoption of crop insurance but reduce the area under coverage. So additionally, we find that social hierarchy has a dominant role to play in adoption of crop insurance. So farmers belonging to lower social status have a limited coverage as well as lower rate of adoption. From this, we conclude that there are certain policy suggestions based on this. We suggest that strengthening financial inclusion through easier access of credit and integrated insurance credit programs shall be taken, and addressing social disparities, especially through targeted support to marginal farmer groups, are essential to increase the adoption. Overall, we suggest that enhancing trust and financial access to farmers and equitable access to crop insurance will help in making it more inclusive and effective and impactful to risk assessment for farm households. Thank you.
So, speaking about agroclimatical advisories and crop production and evidence from southern hills and plateaus in India.
So, good evening, everyone. So, I am Anjaly Unnikrishnan. I am working as a senior project associate in National Institute of Advanced Studies, Bangalore. So, we were working on a project where we are assessing the impact of weather and climate services, especially agrometeorological weather services. So, this work is actually a part of the work we had done. So this is like agrometeorological advisory services and its impact on the crop productivity in southern hills and plateau agroclimatic zone in India. So the agriculture in India is actually vulnerable to extreme weather events like extreme rainfall and extreme temperature, especially the semi-arid regions in the southern India. So this increase in the climate variability is actually putting our smallholder farmers in risk. So there is a high need for providing localized climate services to the farmers, all the farmers. So for that, to tackle this issue, our Indian Meteorological Department has established agrometeorological advisory services, and these advisory services will integrate weather forecast with the agricultural practices, and they will provide both location-specific and crop-specific advisories to the farmers. And the aim of these advisories is to actually enhance the farm resilience and enhance the crop productivity by providing that weather-based decision support to the farmers. And these advisories will provide weather-based planning for a various number of agricultural practices, starting from how to plan this land, how to arrange the land before starting the cultivation, then the seed selection, then sowing, the seed treatment, sowing, then the pest and disease management, then irrigation scheduling, then input optimization and crop management, which includes when to harvest and how to storage the crops. So it covers all the agricultural practices starting from the initial stages of the crop planting to the final stages of the harvesting and storage itself. So for this purpose, Gramin Krishi Mosam Seva, which is launched by Indian Meteorological Department in 2015. So through this, they are providing the advisory services via the agrometeorological field unit. So we have around 130 plus agrometeorological field units across the country. So, and they are providing bi-weekly advisories. All these advisories are released in every Tuesday and Wednesday. In this, they are linking that weather forecast with the crop guidance. And also recently launched Panchayat Mosam Seva, they concentrate more on the weather alerts, through which they are extending these advisories to village levels so that they could improve the last mile connectivity in disseminating these advisories. So there are mainly three important channels for the agrometeorological advisories, dissemination of these agrometeorological advisories. So these are public sector institution extension services like agriculture offices, KVK, then agrometeorological field units. Then comes the technical tools, which includes the mobile apps, especially the Meghdut and Mosam are IMD's own mobile apps, which provides these services. Then M-Kisan, SMS, WhatsApp groups, and radio and TV and newspapers. All these advisories will be provided in local languages to the farmers through TV channels, Doordarshan channels, and also through these apps. Everybody will get in their own language. Then social networks like input dealers, NGOs, their farmers, friends, and cooperative society will provide these advisories. So based on this, we have classified the households into two, what is beneficiaries and non-beneficiaries. So beneficiaries are those farmers who receive the agrometeorological information from any of the above sources, and the non-beneficiaries are those who don't receive the agrometeorology advisories from any of these sources. So the rationale is, there are many studies which shows that the AIS is having a good impact on the productivity. But there are actually very less studies which is providing a quantitative evidence across crops and across different agroclimatic zones. And also the interaction between the advisories, the input use and management practices is also unclear in many of the studies. So our objective is to assess the impact of AES on the yield of major kharif crops. So we are concentrating on 4 major kharif crops in the southern hills and plateau zone, and on comparing between the AAS beneficiaries and non-beneficiaries, and identify the pathways through which the AAS is imposing its influence on the crop productivity. So this is our study area, that is Southern Hills and Plateau Agroclimatic Zone. In that zone, we have selected 3 districts. One is Chitradurga from Karnataka, Anantapur and Nandyal from Andhra Pradesh. So these are semi-arid regions with a very scanty rainfall from 450 to 670 millimeter of rainfall in a year. And the land use, that is like the 50 to 64% of the total area of the district is under agriculture. Then maize, paddy, groundnut, ragi, all these are the major crops, and we are concentrating on maize, paddy, groundnut and red gram in this study. So these are the villages surveyed. So we surveyed total of 9 villages, 3 villages from each districts. So what we had done is we had selected top 5 blocks based on the number of households in each districts, and we made sure that there is one block which is having the presence of any of these extension services, either KVK or AMFU. Then and we have selected the villages based on the number of households, which is equivalent to the district average. And we had surveyed 100 households per village, which is stratified based on the land category. That is smallholder farmers, large farmers, medium farmers, like that. And we had surveyed total number of 762 households in all these 9 villages. So our data collection tools, we had used both quantitative and qualitative data collection tools, and one is the household survey, in which we collected most of our quantitative data. So in that we have collected the farm level data on production, income, input use, and their response to extreme weather and how they are accessing the AAS. And these are actually images of our field assistants collecting data from Anantapur. And then we had done focus group discussion to understand how the farmers are accessing, are there any barriers for them to access the AAS information, and what is the impact they are observing in the AAS information through a focus group discussion among the farmers in each village. So this is the image of our field assistant conducting focus group discussions in Redipalli village in Anantapur. Then we had stakeholder interviews, in which we interviewed the institutional perspectives on AAS dissemination and its effectiveness on the AMFE officials, from AMFE officials, KVK staff, etc. So these 3 are our data collection tools. So now for analytically we had used a one-way ANOVA to test whether there is any significant difference in the input use between beneficiaries and non-beneficiaries. And then we had used a stepwise multiple linear regression to identify the key predictors of the key predictors, and also to isolate the independent effect of AAS on the crop yields. And then we use a propensimetric score matching to minimize the selection bias and to estimate the causal impact of AAS on the yield. So these 3 are the analytical methods we used. So this is some socioeconomic factors. So it is like land holding. So mostly majority of our surveys had small farmers and marginal farmers, except in Anantapur we had semi-medium farmers to be the major. Then literacy status, most of our people are more than 80% of the surveys done where the farmers are educated, they can read and write. Then social categories, when it comes to social categories, other backward OBC categories are the majority, followed by general and then scheduled caste and scheduled tribe. Then the gender, when it comes to gender, most of the households are male headed. Then AAS access. So when it comes to AAS access, the beneficiaries are more than 80%, more than 70% are beneficiaries in all the samples we selected for all these 4 crops. So moving on to the results. So first is the ANOVA results, in which we were measuring the difference if there is any significant difference between input use. So in this there is no significant difference in input use between for groundnut and paddy. But for red ram, we found that beneficiaries had applied significantly high amount of chemical fertilizers, and for maize we found that the beneficiaries had used more manure and chemical fertilizer. So this shows that the access to AAS has influenced the fertilizer management in some crops, and this highlights the need for providing crop-specific advisories. Then comes the stepwise multiple linear regression results. So these are the categorical variables we used, and these are the continuous predictor variables we used. We have 5 independent categorical variables and 5 this predictor variables. So these are the variables we used. So one is social category, which have 4 levels, and then AAS status, which have 2 levels, beneficiaries and non-beneficiary, literacy status 4 levels, and gender, and irrigation status. Then comes the chemical fertilizer, manure use, value of plant protection, then seed rate and crop area. So then comes the SMLRM result. So this stepwise regression has identified the key predictors of the crop. So the AAS axis, the axis to AAS has emerged as a significant positive predictor for all the crops. Then we found that for groundnut, the beneficiaries have had received around 144 kg per acre more yield compared to the non-beneficiaries, and the model is having a moderate fit, and it is showing about 22% of yield in variation. Then comes to paddy, it is showing 407 around 400 kgs of increase in increase in yield for beneficiaries compared to non-beneficiaries, and also fertilizer is also a significant factor which contributes to this yield. And we found that the model is having a moderate fit, and it is explaining 27% of variation in the yield. Then it comes to red ram, it is showing 149 kg per increase for beneficiaries compared to non-beneficiaries, and in this case fertilizer and crop area is also contributing to the yield, and this is having a best model fit, that is 75% of variation in yield is explained by this thing. Then explained by the model. Then maize, when it comes to maize, 100 kg per acre is available for the beneficiaries. Then seed rate and manure is also contributing to this, and it is having a moderate fit, and it's explaining 34% of variation in the yield. So this shows that the beneficiaries of AS is having a statistically significant advantage in yield compared to non-beneficiaries, and with the impact of AS and the impact of AS will vary across the crops. So this, then it comes to propensimetric score matching results. So we had used standard mean difference to assess the covariate balance. So there is a significant improvement in covariate balance before and after matching, and SMDs for most of the covariates falls below 0.2. So that is an acceptable balance. Then this is the average treatment effect results. So we had estimated based on the matched samples, we have estimated the average treatment effect. So this also shows that there is a significant yield advantage for beneficiaries compared to non-beneficiaries, and there is an improved input management and adaptive practices also linked to higher productivity. So in this set we can see that the groundnut is having a 147 kg, yield gap is 147 kg for groundnut, and for paddy it is 410 kg, and red gram 148, and maize it is 165. So there is a strong alignment between the covariate balance, in the results of regression and the results of the PSM. This shows that the results are actually robust. The causal effect of the impact of AAS is actually robust. Then, so these are the key findings. So the result shows that the beneficiaries are having a significant yield advantage compared to non-beneficiaries. And the ATT values are also consistent with both the regression results and the PSM results, and which shows that the causal impact of AAS on the crop yield is actually robust. And there is a slightly higher ATT for maize when observed in the PSM results, which shows that there may be some unobservable factors like soil properties or management practices, which can be explained by the model. Then findings also validate that the access to AAS enhances crop productivity through timely and informed management decisions. So these are our policy implications. So the strengthening the institutionalized multi-channel AAS access will to have for wider farmer reach, and promote the crop specific advisory, particularly which is tailored for rain-fed systems and irrigated systems. For example, for rain-fed systems it will be better to focus more on nutrient and soil moisture management, and for irrigated system it is better to focus more on weather and pest or disease warnings, and enhancing the accuracy, timeliness and the accessibility of AAS will improve the crop productivity and will contribute to the food security. So, okay, thank you.
Detailed one, of course, and sticking to the time. I'll now invite Piyush Priya, Aparajay Kumar Singh and T. Jayaraman. All of them, I think, work for the MSSRF Chennai, and I'm told that Aparajay will be joining online, right? Yes. So I'll invite Aparajay to speak on the differentiated impact of carbon pricing in Indian agriculture.
Aparajay, can you hear us? You can share your PPT and start the presentation.
Thank you for this opportunity, and this presentation would not be possible without expert and the work that Thomas work that Piyush has put in. So I'll share my PPT and go to the presentation. I try to make it as quick as possible. I'm sharing my whole screen so that when I share my PPT here, see the my screen visible?
Yeah, it's visible, Aparajay.
Yeah,
We can just minimize the top.
Here, it's a kind of trying to see the impact of carbon pricing on the Indian farmers through an example study. The example study, we because there is no such taxation in place, carbon tax is significant. We have to resort to example to do so. But why I thought that this is actually an outcome of a concern that we will discuss as far as pollution, as that with this movement away from legally binding and after the disagreement on relying on carbon pricing, basically carbon which is as its theoretical foundation in those theorem, and carbon tax which has its theoretical foundation in the European tax, to basically try and lessen the carbon emission. So, what would be its impact in terms of distributional impact on the Indian farmers? So, how best to one can study that? One approach is to take an external critique, pick up some kind and understanding of this is a legislative usually does the government have so much of information inside what social costs. Or one is the technical critique of commodification of nature. You are not really questioning that. And indeed, metabolical capitalism causes and there is a kind of contradiction between use value and exchange value from Marxist perspective. But all of this look like more of a kind of normative theory which for policymaker doesn't kind of really go into the what we take in turn was to go into an internal critique, where we don't really question the neoclassical or the foundation on which these kinds of policy suggestions are based, but rather look at it, what is the fallout of this from the distribution point of view. This was our motivation to look at it. And research I mentioned, and we found that actually the findings are that it is regressive, and I'm not going into details of that, except land-rich countries like Brazil and all. It's not only regressive in the sense that marginal and small farmers are more impacted, but also in the sense that there is a threat to food security. And so to mitigate, kind of take into account and try to do something about this adverse impact of food security and the regressive impact of carbon tax, what was being suggested in the literature was to take up recourse to some kind of recycling. So even in the recycling, the manufacturing way was found to be not really able to turn this regressive outcome into a progressive. It was more about food subsidy. And there is the literature on that as well, what kind of recycling it should be done. So there is almost a consensus that there is a regressiveness to carbon tax, at least in agriculture, but what we can do is recycle it and in terms of some free energy to all, or be it cash transfers to the poor, in terms of food subsidy and all that, we can kind of do something about it. But the very fact that it's regressive, then why not devise some policy which will not really impact small and marginal farmers, because to kind of impact them adversely and then they can do something about it. At the first time, this may not be feasible. It may have an adverse impact on small and marginal farmers, but at the end, when you are recycling, it may not reach that. So why not make recourse to that? And is it true that India's case also a carbon tax will have a regressive impact, or is it something else? So to do so, we kind of try to because in India the market is not really penetrated so much in the sector. So it's basically farmers are more bothered about the cost part of it. So instead of looking at the profit function, we look at first we should look at the cost function. And in the cost function, we try to kind of taking the assumptions of the new investment model, but try and keep it as realistic, make it as real as the farmers for the farmers. So what we did was we gave a transfer cost function. A transfer cost function allows you to have this variability in terms of capacity of substitution, also kind of factoring economies of scale that one can experience with farmers marginal to a large farmer when you're working on a large farm, there are certain economies of scale that one enjoys. So that is captured well in the transform cost function kind. And to estimate it, we just followed the literature of using the CEP unrelated estimation Ishawar model, which basically kind of estimates cost functions along with the share equations, the share of each input in the total cost. Because the error terms are have some kind of a correlation, so it's best to kind of estimate all of them together. The data source that you use is the cost of calculation data from Commission of Agriculture Price Costs and Prices, and the year we took was from 2014 to 17 as we said. We could make it. The cost price data were given, we kind of put them all together to make it for farmers, and we tried to take into account all the crops that they were cultivating except coconut, because coconut is differently as compared to other crops. All other crops, the pricing is per kg in terms of coconut. It's slightly different, so we had to factor out the coconut part. But apart from that, we had all the costs. This was the cost function we used. This is the thing. The prediction part, before we did the prediction, we made some correction which we found in hydrology and literature that was not really there in the economics literature, where you take a log estimation, then you need to correct for certain biases that we have to and we did that too. Before we estimated, before we predicted the new cost that may arise due to tax on fuel and fertilizer. Once we got the new cost, then we found that what is the percentage change for different groups of farmers, from marginal, small, medium, and large. And by comparison, we could then say whether it's regressive or not. If it is regressive, then why so? And if it is not so, then what would be the possible difference? So this is what we did, and the results, before we go into the results, kind of overview of our sample. The sample was represented, we had all the groups of farmers represented in the sample. And what we found that if you look at the shares of each crop inputs, we find that it's majorly animal labor, human labor, fuel, not so much of animal labor, human labor, seeds and fertilizer. These are the major shares of input to the total cost. Now the results we found was that it is regressive. Now it is regressive not only when we not factor out the economics of scale, the cost advantage that the large farmers have because of the economics of scale. Then if we factor that out, we still get that is regressive. Now it is not regressive like in the sense, largely it is marginal and small, bearing the larger part of this taxation, and same medium and large, not so much, they are almost similar. So this is the kind of thing, but why so? On the reason could be found if you look at the change in the share of different inputs that would be. So we found that animal labor usage increases and increases more for the small marginal farmers, because they do not have that kind of an option necessary to kind of still use machine and the machine fuel price goes up. The other thing is that if you look at the the taxation of fertilizer is not really kind of, we are not really able to kind of move away to manual, especially the marginal farmers. They are still sticking with fertilizer because of, in terms of share at least, because first the availability, and second, because there is a possibility of a fall in yield, enormous fall in yield. So what we found from this was that, and then there are business crises because there is this elasticity between fertilizer, the elasticity association between animal and fertilizer is much less. And this being substitutability is because not only contain more food, but also because there is a lack of availability of so much of manual. So this was the result that we were asking. Now one can just conclude that it is a regressive tax, but it is not so. It will also lead to a lower usage of machine. I note that the action of Indian agriculture is still much lesser than the other countries, but it will lead to nation farmers and not go for further manufacturing will affect the productivity and hence the food security that we have achieved over these years. So this was what we have to say for this presentation. Keeping this in mind, the policymakers should be a kind of think of other ways to kind of, if at all they want to do it in case of agriculture. But agriculture, as you know, is not really contributing so much to the carbon emission. So the question is why agriculture? Why not see other areas? And are also the question what the developed countries have been historically more responsible for this catastrophe, whatever we are facing, in terms of emission. Why are they? How much they are responsibility for that? So thank you very much.
Thank you, Aparajay. I hope it was audible. I kept asking everyone, I hope it reached all of you because it's interesting work. And I suppose this is the first time that anyone has looked into the effect of climate change. So thank you. Now I'll invite Rakesh Gomaji Nannewar, Anjaly Unnikrishnan again, Kritika S, Chavamati Kashinaju and Tejal Kadikar. Again we have another paper from NIAS, Bangalore, which talks to us about the agrometeorological advisories.
So this is the work of the team of NIAS. I will be presenting on behalf of the whole team. So my colleague Anjali has introduced the AAS to all of you. I am going to the backward side of the AAS, which is what drives, what influences these agrometeorological advisories access and utilization. So the outline of my presentation will be, I'll start with the brief introduction, methodology and findings and conclusion. Okay. So as correctly pointed out in the morning, Professor Jayaraman also said that the extreme events are now visible and we need to work on the adaptation part of the climate change. So it's urgently needed to protect the farmers' livelihood and the productivity. So what is the basic purpose of the agrometeorological advisory services is to bridge the scientific research and the farm level decision. So this is to bridge that scientific research and farm level decision making by the farmers to manage their weather variability and improve their productivity and reduce their crop loss. So by keeping in this mind, the IMD has started the agrometeorological under the Gramin Krishi Mosam Seva. They started providing the advisory services. Can you speak near the mic? Yeah. With the collaboration of the ICAR institution and the State Agriculture Institution. So the AS generation unit, IMD generation unit are most two main units through which the advisories is being prepared. Two main institutions through which the advisories is being prepared and disseminated. First one is Agromet Field Unit, which are located at the state agriculture universities and the agriculture research station. And second is distinct agromet units, which started in 2019. But they have been discontinued from 2024, which were located at the Krishi Vigyan Kendras, and they were responsible for the preparing block level advisory services. So I'll introduce how the AS network is. So basically the AAS is a multi-institutional and multidisciplinary project. So it works on the four aspects, the four disciplines. First one is meteorology, agriculture, extension and dissemination. And it works in three aspects. The main aspect is preparation and dissemination of advisories, then making feedback and awareness of these agromet advisories among the farmers. Third one is to train the officials of the AMFUs and DAMUs, and through which near about 43 million farmers were benefited under these schemes in 2022. And which are the institutions involved in this advisory services? First one at the top level, Ministry of Earth Science, then at the state level, Department of Agriculture and the agriculture universities, and at district level, district agriculture officers, KVKs and ATMA, and at block level, BDO office, and at village level, CSC centers. So this is the theoretical thing it should follows in order to get timely and orderly dissemination of these advisory services. So how this AS functions? So it functions on the 6 pillars. First, the past week weather conditions from the institution, which are the AMFUs, observatory station, IMD collected, and based on that information they prepare the weather forecast for the next 5 days. After that, the AMFUs prepared the agro advisory bulletins. After that, the bulletins is been sent to the expert committee, which is mainly agriculture universities experts. After that, compilation and update on website, and the last step is to it get disseminated to the farmers. So what exactly the advisories, this bulletin looks like? So this is the yesterday's bulletin for the one district known Chandrapur, and if you see, this is the past 5 days weather forecast data, the observation data, and based on this, the IMD has provided the forecast data for the next 5 days from 8th November to 12th November. On these parameters, the rainfall, minimum temperature, maximum temperature, then the morning relative humidity, afternoon relative humidity, and the wind speed and wind direction. Then for the farmers, the SMS, the general advisories, which will be provided like this one, the small section which the farmers get in the form of text. This is the one part of advisories, which is weather forecast. Second part is the agronomic advices. So first one is the general advice which has been provided. So now we all know that the Kharif is about to over and we are going for the Rabi. So they will tell the finish it. So this is the specific to the crop, like the wheat, the crop, then crop stage, and based on that crop stage, that advisories are there. So now we are in the sowing stage, so they will provide which variety to use. So which is the detailed advisory service is been provided to farmers. So by keeping in this mind, our objective of this study is to determine the assess the farmers' assets and the utilization of the AS. Second objective is to determine what factors are responsible to assess and utilization of the AS. And the third objective is to evaluate how this assess translates into the practice. So I'll not go into the details of study area as my colleague Anjali has already explained. So, okay. So for this analysis, I have used the two model, which is the order logic model to assess the determinants of the AS assess, and Poisson regression model to determine the influencing factor of the utilization of the AS. So AS assess score is the measure of the advisory breadth of the advisory assess. So we have asked in our survey whether they have received the agriculture advisories or the weather forecast. So we have separated that. We have separately asked the farmers whether they have received the agronomic practice related advice or the weather forecast related advice from the different channels. And the utilization breadth score is the what type of during what stage they have used what type of advice. So that details we have asked, and the frequency of these advisories, whether it is rarely, weekly, or occasionally they have received. So that also we have asked. the last thing is the use to receive gaps, whether how much advice they have received and how much advice they have used. That also we have asked, and we have, okay. So based on this assess score, we have divided household into the 3 categories. So first one is no assess, where farmer do not receive any agronomic related advisories or the weather related advisories. Second is partial assess, where farmer received the either agronomic advisories, advice or the weather advice, weather forecast through informal and institutional sources, not from the digital sources. Here we are not considering partial assess or digital sources. Where full assess is where farmer has received the agronomic plus weather advisories from the institutional sources and digital sources. Where we are considering farmer as a full assess, means he has assessed AS fully. So these are the descriptive results which Anjali has shown before. So I will not go in details. So I'll go to the model results. So based on based on this, we have identified 80% of farmers has the partial access to the AAS, and the no access is 94 farmers, which is 12%, and the full access is 62 farmers only got the full access of this AAS. So the model result shows the key determinants for the access of AAS is which influence the access to AAS is the landholding size and social category. So the larger farmers have significantly higher odds of the AAS access, and every increase in the land class raises to access of odds by the 21%. And same with the social category, where we have observed that the OBC has a 47% lower odds of the high access compared to the general category. We have kept general category as a reference point, and the scheduled caste has 93% odds, and the scheduled tribes face the greatest advantage, which has only 2% odd, and all other factors were non-significant. So based on the model, we have predicted the access into two category of farmers, where the low capacity farmer profile and the high capacity farmer profile, where we have identified for the low capacity farmer profile 50% chances of the no access, and only 1%, only 5%, 0.5% chances of the full access for the low capacity farmer profile. And for the high capacity farmer profile, we have identified 84 chances of being a partial access. So even though all the resource will have by the farmer, he has more chances of the partial access rather than the full access. So access to AS is mainly shaped by the structural inequalities, particularly the landholding size and the caste. Okay. So the second model, the Poisson GLM, gives the determinants of the AS utilization. So the frequency of advisories become very important to utilize the AS here. So the most powerful predictor was the frequency of advisories. Each unit increase in the frequency score lead to 58% increase in the advisory uses. Okay, so it shows that the regular information flow keeps farmer engaged and encourage the practice adoption. The second predictor was the barriers, the challenges. So each additional challenge will reduce 12 to 13% decrease in the uses. So these challenges are like the time issue, then the language issue, language barrier, then the access to extension institution. These are the challenges we have asked for the farmers, and it shows that the challenges in access sharply reduce the effectiveness of the AS uses, and the other variables were insignificant. Okay. And the last is use ratio gap. So we have identified they have received on an average 2 advisory topics, and they have used 3 topics. So they have used more than what they have received. So this phenomena we have identified where use to receive ratio was 1.64, meaning farmer used 164% of the topics they have received. So why is it so? So farmer actively apply their own judgment to extend the limited advice into multiple farming decisions. So if you are getting the rainfall advisories, so based on the rainfall advisories, 2-3 crop operation decision they take. So that's why the farmer combine the farmer AS with the informal sources. Also, they don't just believe in the advice, they ask in their social network or the peer group. So that's why evidence of this peer learning which has been identified through this. Okay. So the key finding was the access to AS is unequal, where the larger landholder and the advantageous group like the OBCs have better access to AS. Then the structural barriers drive inequality, where the landholding size, caste and institutional delivery issue. Institutional delivery issue where I am seeing the frequency. If you are increase the frequency from the occasionally to weekly or the daily basis, or the way the advisory is prepared weekly twice, the usage will increase. So farmer use more than what they have received. And barriers are actionable. So these barriers which has been faced by the farmers are generally actionable. So the key strategic takeaways from this study is we should treat AS as because it's a critical public good, like the irrigation and road, what we considered it as a public good, especially in the context of climate change. Then the beyond dissemination AS is a dialogue where for the preparation stage also, the agromet observer and the official take the on ground situation for the preparation, and it's a systemic integration needed. So it should be included into the agriculture and climate policy linked with the agri extension. So I should be thankful for the Ministry of Earth Science for funding this project. Thank you.
Thank you very much, Rakesh. Again, a very interesting presentation from the NIAS team. Now we move on to the final presenter. It is Ishawar Choudhry, who will be speaking about climate change, adaptation in Indian agriculture, a household level analysis. So I will invite Ishawar.
Ashwar Choudhry, and I will present climate change adaptation in Indian agriculture, a household level analysis. For arid and semi-arid regions of India. So, climate change is a major issue for most developing countries, and we can, according to IPCC AR6, arid and semi-arid regions around the world are most vulnerable to climate change, and already they are facing most of the impact of climate change. So, in India, if we see the Indian agriculture system, then already most of the farmers are the small and marginal farmers. And along with the climate change, their productivity is declining over the period of time. So there is a urgent need to assessment of adaptive capacity of Indian farming household in order to adapt to climate change. So if we see the why we have chosen the arid and semi-arid regions, the major motivation behind choosing the arid and semi-arid region is that they are more exposed to climate change and they are more sensitive to climate change, and the potential impact will, according to IPCC AR6 report, potential impact of climate change on these regions will be higher in the near future. So we have that's why we have used choose the arid and semi-arid regions of India to our study. Now, what is the adaptive capacity? So adaptive capacity is the capacity of system, our institutions, our individuals, our other species to adapt to possible harms or exploited opportunities or react to consequences. Our adaptive capacity refers to the feature or behavior in order to better handle the climate crisis or circumstances now the world is facing. In addition to its common meaning, it also encompasses the skills or resources and institutions necessary for the successful implementation of the adaptation strategies. And adaptive capacity is crucial in order to develop efficient solution to mitigate the climate change impact. So, current body of literature suggests that one of a study by Majid and Salvia from the northern region of Ghana indicate that economic resources along with awareness and training have higher impact on adaptive capacity, and infrastructure and social capital have lower impact in like if we compare the different dimensions of adaptive capacity. One of another study by Masfin for Central Rift Valley of Ethiopia suggests that institutions and entitlement, knowledge and information and innovation contribute to more in adaptive capacity rather than governance and asset base. One of a study from Datta and Behera, this is the primary service study from the eastern Himalaya footfall of West Bengal, India, suggests that 11% of farmers have higher adaptive capacity, 60% of farmers have moderate adaptive capacity, and 28% farmers have like less adaptive capacity. One of a study from Zato and Nayak using the NSSO data and Agriculture Census 2015, they have analyzed that in Indo-Gangetic plain, trans-Indo-Gangetic plain have higher adaptive capacity than the lower Indo-Gangetic plain. So different literature suggests that there are different dimensions of adaptive capacity. The major dimensions of adaptive capacity are innovation, knowledge, institutions, asset, and decision making and governance. So based on these dimensions, we have identified the 6 components which is also used by the Jatov and Nayak in their study. Similar kind of indicators they have also used. So we have identified the 6 indicators: physical resource indicator, financial resource indicator, human resource indicator, social resource indicator, livelihood diversity, and information accessibility. So based on these 6 components, we have constructed the 6 sub-indexes, then we have created an aggregated index for adaptive capacity. So the area of the study is the arid and semi-arid regions, and we have identified the arid and semi-arid regions based on the method which is used in the which is based on the UNEP in 1990. That is the aridity index, which is also used in the IPCC AR6. We have used similar kind of analysis, and we have taken the data from Terra Climate, which is also used in the IPCC AR6. So we have identified 165 districts which are in the hot, arid and semi-arid regions. And we have used the indicator-based approach to construct an index, and finally we have used a multi-nominal logit model to analyze that which indicators have contributed more in making the index. So in estimation method, we have normalized each indicator which were not in percentage. So for positive indicators, we have normalized the actual value minus minimum value upon maximum value minus minimum value, and which indicator which have negative impact according to literature, we have normalized them based on the maximum value minus actual value upon maximum value minus minimum value. And we have used equal weights for each of the indicators which are used in the each component. Finally, we have constructed the aggregate index based on the each of 6 component, and we have used one equal weight which is 1 for each of the component. So the variable we have used the NSS 77 and 17th round, 2 rounds of data have used for this study, and these are the different indicators for each of the component we have used and their descriptive statistics. So for physical resource index, we have used average area of land, area under marginal farmers, and the farmers owned land, percentage of farmers who own land. For human resource index, we have used the percentage of farmers have agriculture training, literacy rate, average age of farmers, working population in the household of the farmer. Then for social resource index, we have used female headed household, farmers living in joint family, and percentage of farmers taken information to progressive farmers. Then for livelihood diversity index, we have used the two indicators: income from farm produce and whether the household has a MZ job card. Then information accessibility index, we have used the three indicators: farmers having access to KVK, aware about the MSP, or have taken information from TV or radio or other electronic devices. Then financial resource indicators, we have used the two indicators: crop insurance and institutional source of loan. So we have analyzed the adaptive capacity score for the arid and semi-arid regions. We can see for the combined aggregate index. If we see in the 2013 and 2019, the major corridor where adaptive capacity is higher is the eastern Gujarat, Maharashtra and Karnataka, because of historically they have more financial resources and literacy rate and other things. And we have used the multinomial logit model to assess which indicators are have more weightage in adaptive capacity score. Finally, the result suggests that Gujarat, Maharashtra and Karnataka corridor now lead the dryland gradients, and because of the historical infrastructure, our rapid insurance uptake, while Eastern Rajasthan and Bundelkhand region still lag in this in overall. And in India's dryland made miserable progress in 2013 and 19. However, the progress was in the this corridor only. If we see the Western Rajasthan and Bundelkhand, they have lagged. Insurance, institutional credit, and access to Manrega job card emerged as the three largest single levelers to household adaptive capacity score, and confirming that liquidity, whether ex ante or ex post, is still underwrite most climate decisions. Information flow from KVKs, progressive farmers, over digital platforms, and positively interacted with finance validate that knowledge is still knowledge and money are working as a complementary, not substitute, as other studies are showing. So human capital gain, especially rising literacy, reinforce these drivers, whether land expansion mattered only on the larger farmer. So human capital gain, along with the labor-intensive diversification, continue to be to pay a resilient dividends. Finally, the conclusion suggests that insurance is the major driving factor in adaptive capacity. So there is a need to strengthen the Pradhan Mantri Fasal Bima Yojana or other crop insurances to enhance the adaptive capacity in these regions. And if we see the multi-skill challenge, then information accessibility also a major factor. So there is a need to strengthen the advisory services over other information along with the agricultural training. Third emerging factor is access to Manrega over diversification of income from agriculture to non-agriculture over within agriculture needed. So formalized land rights, because if we see the physical resources also a important factor in adaptive capacity that is needed. Otherwise, physical capital deficit no longer swap the financial will swap the financial gains. Finally, mainstream crop livestock diversification incentive and short season pulses, fodder bank and small remnant credit lines to preserve the adaptation edges of marginal farmers as plot continue to shrink as suggested by the Bahinipati and other studies. Thanks.
Thank you very much. I forgot to mention Ishawar works for BITS Pallavi.
Yes.
Right? Yeah. Okay. Now we have time for the discussion. And may I invite Kiran Kumar Pudi from GIFT. He works for GIFT Trivandrum. So over to you.
Thank you, Chair, and thank you. I'm not going to get into the discussion in great detail, but I'll try and summarize the major points and some considerations for improvement, mostly on the methodological front. I'll start with the first work, which has looked at the adoption, the factors that contribute to for adoption of crop insurance scheme in case of agriculture. Very interesting paper, and I think we don't have many papers as of now to study what constrains some farmers from adopting this particular scheme. To that extent, I think it's a very interesting question to begin with, and the author has also done a very detailed field survey to explore this particular question. Now, here I have a set of suggestions, if you can call them, and maybe that will help you improve your paper when you are revising it for publication. One of it I felt was that, and this particular comment is also true for other papers to follow, is that we have to anchor a research question in a proper theoretical framework. And there are vast set of models that talks about what determines adoption of a particular, because this is more of a self-selected process, right? It is not given by anybody at all. So why is it that some farmers are doing it and why some farmers are not doing it? I think there are literature or theoretical models that basically follow that. Or let's say if we broadly categorize them as farmer sort of characteristics, and then look at whether it is more of farmer or farm set of characteristics, because you studied for one crop, so I'm eliminating the crop and regional parts in it. So that's one thing that I think you would study, or at least give a theoretical underpinning for the paper, so that some of the findings that you are coming to in the later section could be related to broader theory. The second part is about the sampling strategy. See, you have taken eight villages, and if I understood correctly, you have taken 2 villages from each block. Yes. Correct? And one from high adoption region and another from low adoption region, or something like that. So could you just explain why is that taken? That clarification would be helpful. The other aspect is about, in the paper, I'm talking about, this particular point is from the paper. You have said that you have adopted a multi-stage sampling procedure. Fine. But could you please explain the randomness in selecting a particular household growing soybean after you pin down the village? Because you said you have randomly selected the households who are producing soybean. So unless you have the list of people who are producing it in a village, random selection could be difficult. So that point maybe you can clarify. The other aspect is when you are running the model, you have motivated it saying that your study is different from the rest, while other studies have essentially focused on whether or not farmers adopting this particular insurance scheme. You are going a step forward and saying that you are also looking at area covered. That's an interesting way to look at it, but when you are asking area covered, maybe one way to check is what proportion of the area covered.
Yes, sir, actually right, but there was a problem of multiple area because the area owned by farmer and insured by farmer both were same, so it was not coming in order. So we had to change it to area shown.
Yeah, but then see, area covered, will that be really taking care of the next set of questions that you want to ask? And also when you are writing it could be useful if you are giving a proper justification why there could be factors that affect only adoption but not so much on the area. And interestingly, your results show opposite signs. In some variables you found that it positive, some factors especially that showed a positive effect on adoption but not statistically significant effect on area covered. That I thought would require a little bit of more detailing. And another part that I was thinking is the
I
problem.
would request you to be little fast, because after that we have to give them time also to respond, and we have to open the floor also for questions.
Sure, I'll summarize it fast. The next part, maybe the important part I thought was the potential indemnity problem, because you've already taken credit and see, credit and insurance are linked. Suppose you have a farmer who is already having a disability card. Disability card comes with insurance, right? And and some of it, and some credits are having the insurance as a prerequisite. So that would create biases in your result. The last point for this particular paper is, since you have categorically mentioned, for 8 districts, one option is to add a district fixed effects.
Yes,
So that it will be that. And last, I think it's there in your presentation, but it would be always useful to describe your data in a little more detail so that we can get an idea of how your data is. The second one is about, I combine these two because essentially both of them have used the same sample. So this was again a very interesting question to assess the usefulness or to what extent agrometeorological advisory services are effective in increasing crop yield. Very interesting question, and actually you can anchor this study broadly in the literature of factors that affect using a particular source of information, because this is also a kind of information source but specific to address some of the climate change problems or environmental related issues. So I'll quickly run, it's a very extensively done, different districts in 2 states and so on. My particular question to you, or at least a suggestion to you, is you have run 3 sets of different models, ANOVA and multi-stage, and then you have gone on to do KSM. But if your purpose is to really estimate the difference in yield between the adopters or non-adopters, you could simply have gone to the PSM and tried to do a more robust work on that. Even there is a slight problem. If you look at the data distribution, you have already mentioned that 80% of them have adopted. Now, see, usually when you go for a tool like PSM, the prerequisite is that, it should be other way around, then only you get a proper match.
We are taking like that way. It's like except of not receiving eggs. So they get how much negative validation they possess.
So Anjali, I think you can later to respond so that others also can.
Yeah. So that's one thing I thought, and the other part is, see, when you are showing that these particular services have advantages in terms of improving yield, you have to talk about the mechanism through which it is going to happen. And since you have already the next set of presentation discussed it in some detail, so there are various degrees of adoption. At the moment in your analysis, we have just treated adopters as a homogeneous category. But in the next presentation, we have seen that adopters are not a homogeneous category. When they are not homogeneous category, the likely effects of yield could be different, right? And also you could differentiate from the source of information. So that I think would add to a policy also, which sources are predominantly contributing to yield improvement, which sources are slightly ineffective in terms of contributing to yield improvement. That I thought could have been explored a little more, and you have the data to do it. I hope you will do that in future. And see, another part is when you are running the regressions, you are running it for 2 states and different districts. So it's better that you have a district and village fixed effects control. Otherwise, some of these unobserved district effects could dominate your results, and that could be biases in your overall result. Okay, I hope that will be taken care. And the next presentation is on the it is a paper that is linked to this. Okay, now I just talk to one particular point when you are doing this I'm trying to assess to what extent people have adopted, and could you please clarify why you have gone for a poison count model? Because see, you don't have so many count observations in your data. It's a scaling variable, right? It's maximum going up to 4 to 5. So in my view, it is not an appropriate model, especially when you don't have too many counts, and that varies significantly. All right. And the other one is you could have also looked at this particular question because you have non-adopters, partial adopters, and full adopters. One of the easy ways to examine what factors determine it is also through a multinomial logic model. That would have given you a more robust results. So I'll stop on this particular paper first for the time being. So the next paper is about differentiated impact of carbon pricing on Indian agriculture. Very interesting, and especially because this kind of questions have not been asked in Indian context, I think, to the best of my knowledge. And also, it's an empirically quite rigorous work. But I will be asking a set of questions, maybe out of the realm of the current paper, but the question that immediately came to my mind was why the authors have gone for CACP data when we could have done that with situation assessment survey of MSSO, which is a slightly more recent year, and all the information that the authors have used is also available in that survey. So one clarification only. And the other part is, it's interesting that the paper starts critiquing the neoclassical models, but the analysis, at least the functional form of it, is purely neoclassical. So to what extent the objective of taking a critique on the neoclassical approach to understanding, at least say, let's say, productivity would really differ when it comes to estimation. We are confining to the very so model with restrictive assumptions. The other one is a particular clarification, wherein in one of the tables it was shown that the cost elasticity of human and animal labor with respect to machine fuel is 1.2 to 1.3. And that's almost like a near substitution, and I think it needs a bit more careful explanation as to why this perfect substitutability comes in. And the other one, I didn't really understand the details. I'm sorry for that, but it would be nice if you could clarify what's your entire sample, how many crops you have covered, and then bring in the heterogeneity in it. That's one thought, one thing that I thought. But conceptually, what I thought also was, why is it that one would expect the carbon taxes to be regressive, especially for the marginal and small farmers? What is the mechanism that works behind it as compared to large farmers? So that clarification would be helpful. And coming to the last one, climate change adaptability, and the author has done a very extensive work on understanding or at least estimating the climate change adaptability. Yeah, the author has estimated climate change adaptability index. Here I have a couple of suggestions. See, adaptability could be high not just because of the factors that you have identified, or two different pillars you have identified influencing climate change adaptability. Because see, some of the districts that you have seen, the districts themselves are structurally very different in terms of climatic risks. So if the climatic risks are significantly different, the adaptability also could be different. So it's a function of the climatic risk that the districts are in, and the households that are in the districts where if the climate change risks are high, obviously they will be having higher adaptability, at least theoretically, or they will be trying to have that. So if you could have distinguished that particular part in your analysis, and then put this particular set of factors that you identified as key factors for adaptability, would be more revealing. These are my initial set of observations. Thank you, but I enjoy reading all the papers.
Thank you very much. There is anything here, but in case there are any comments or questions from the audience, I am just opening it up. Are there any questions? Okay, so I'll just ask a couple of questions and then we'll go in the reverse order and give the authors a chance to discuss, maybe 2 minutes each later. So one thing I wanted to ask Ashish is very correctly what Kiran said is that credit is linked to insurance. The minute you take credit, you are automatically paying premium. I think the greater question is about claim settlement. You should look at that issue because you have survey data. What is it that is affecting claim settlement? Because one of the things that we say about this insurance scheme is that it is yield based, right? So the yield has to fall below the district average, or now they are talking about the block average. So what are the factors? Because many of the times it is because of lack of claim settlement or delayed claim settlements that farmers are discouraged from seeking insurance. So it's not merely access. Access everybody has because everybody is there is a saturation of KCCs. We are talking about saturation of KCCs, saturation of insurance. It is more to do with what is it that they need to be using that scheme and what is it that prevents them or what are the hurdles there. Those I think need to be assessed, and since you have the data, I think you can look into it in greater detail. On Anjali's paper, I had a comment, and you talked about this red gram being the effect you saw was much more for red gram as compared to paddy. I'm just surprised, what could it be? Does it have to do with the quality of the advisory or something? So maybe you could explain that in some a bit detail. And also at one point you say that it is the fertilizer use which is affecting it. It is showing you saw a difference in using ANOVA, right? So fertilizer use is leading to an increase in productivity also. So there is again some sort of endogeneity because AAS is helping, but AAS is also helping fertilizer use, and fertilizer use in turn will also affect productivity. So maybe you could just look into that. I was not very clear how you are able to distinguish and parse out the two effects. And yes, the same paper, Rakesh and others. So what I could not understand is at one point you said that 8% of the farmers have full access, and that's very low, right? But they have informal access, right? So they do get what's the problem in having that? Is there a leakage of or misguided information that's coming through NGOs or something? What is the problem really of having even an access to non-institutional or informal sources? Because ultimately information is information. So I did not quite understand what is it that, because I don't work in this area, so I was not very sure how it works. So you could just throw some light on that. And one thing is, yes, it's true that AAS is helping farmers in dealing with climate change. But now IMD is increasingly, whenever we have meetings with IMD says that they find it very difficult to forecast weather because of climate change. There is so much of volatility. So even giving a forecast for tomorrow or 5 days becomes difficult. So this is just a comment that on the one hand, there is no solution. We need AAS, no doubt about it. But the point is, even the AAS is subject to a lot of uncertainty or not really the information not being adequately captured because of climate change and the volatility associated with that. And at one point you also said that language gap is a factor, is a barrier. But you showed us the advisory which was very much in the vernacular languages in Marathi, right? So why should language gaps? As I said, I don't work in this area, so I was not very clear. You can just throw some light on that. I think now what we'll do is we'll go in the reverse order and give the authors a chance to explain or give their comments. Ishwar, would you like to speak something? Or Suljit has a question.
If there is time.
Yeah.
So how do you define full access and partial access, and how do you measure it? Because my understanding is that you digitally transmit the advisories, and then so how do you define a farmer has full access and a partial access? And second, you said there is a socio-economic category differentiation in access to this. So what is the mechanism by which that is being, a farmer belonging to a particular socio-economic category is discriminated against accessing? And then accessing is one thing, and then utilizing is another thing. So how do you? I'm asking because of ignorance.
Insurance system can improve a better return to the farmer or trade. So from trade ingredients, what is the avoiding suggestions to have better adoption systems?
So I think now we go in the reverse order. Ishwar, would you like to respond to him? And
When it comes to adaptive capacity will be impacted from this. I think
I think adaptive capacity will not be impacted by this authority like no. According to me, vulnerability will be function of risk or exposure and adaptive capacity. Not adaptive capacity will be function of exposure or whatever the risk you are talking about. I think it's like
Rakesh and Dean, would you like to respond? 2 minutes, okay?
So the first question was, and definitely use the other model. Ma'am, regarding informal sources mainly the input dealers, so which are given by the agenda. So
NGOs also.
NGOs also, but mainly the input dealers. If you know, there are some Prakash, those type of weather advisories, the weather person. So that's become problematic. And scientific language, which I am saying, is the scientific language of science, in terms of science, because that other and those terms needs to be understood. So that is needs to be trained. So farmer awareness program is a part of aspect of the advisory. Sir, the categorization of the full assess, no assess, and the partial assess is based on the assess score. So I have identified the full assess category is the person, the household which is getting the advisories from the institutional sources and digital sources. So he will must be receiving the text messages or through the WhatsApp group, and he also visited the agriculture officer. So one of the analysis was the most trusted source of the farmer for the AS is the agriculture officer. So that is the full assess. The partial assess is the from the informal sources, mainly the peer group or the input dealers or cooperative societies or the other farmers. So those are the informal sources through which the household is getting the advisories, which he did see the bulletin. Okay, so that becomes partial assess, and no assess is the person who do not receive any, and he is dependent on his experiential knowledge. So that is the case. Thank you.
Yeah, okay. Aparajay, you are there? Why don't you?
Sir, actually, you have asked about that thing that in our study we had used that non-beneficiaries as treated. It should be the other way, but we have less number of non-beneficiaries and more number of beneficiaries. So we had took non-beneficiaries as treated, and the control group is beneficiaries. So it should be like the effect of not receiving AS. So the ATP is like the effect of not receiving AS, average treatment effect. So it will be negative values. We have this negative values we used to get, but I put the this absolute values there.
Sir, suggestions on PSL we can discuss it with you.
Yes, yeah. So as ma'am, you asked that fertilizer.
Yes.
Fertilizer thing is like in this advisories they used to give advice for fertilizers also. So what people usually use that they will get this NPK and some chemical fertilizers for subsidized rates. So it is like for 1 acre this much quantity they will provide. So everybody will use them. So those who follow the advisories, they will know exact quantity and exact what crop stage they have to use. So if they adopt that, that will actually increase that. And then as you mentioned that beneficiaries are a homogeneous group. So it is like everybody is getting somewhat of some information. So weather forecast, everybody is actually getting information on weather forecast. So even if they are not looking at the crop advisories very thoroughly, they are actually managing their crop activities based on the weather. So it is like if rain is forecast for the next 5 days, they will be postponing their harvest. So in that case, it is also affecting their crop yield. So that's why in the initial study we took as a 2 groups of the beneficiaries and non-beneficiaries, and he had more detail in. Yeah. So then as you asked about the forecast. Actually, we also studied about the accuracy of the forecast for these districts. So for the 2023-24 year. So it is like most of the forecast, especially rainfall is pretty good and sometimes it is moderate. So it is like in a season if they make some 100 forecasts, if 70% of the forecast is true. If rainfall is predicted and if it is happening, and for 70% of the times, then it is like as per the WMR has some guidelines for
Yes.
As per that, it is good. And if it is 50% more, it is moderate. So for we had found that almost all the rainfall events that is happened is actually predicted correctly. Plus, above that is a lot of rainfall events are which is predicted extra also. What is predicting, over predicted. So what happens is the farmers were also complaining whenever they say the rain will happen, the rain is not happening. But actually they captured all the rainfall events plus some extra also. So that is in a way 70% of accuracy is actually very good in the topic.
Okay, thank you. Aparajay, would you like to respond to Kiran?
Yeah, just I think three major suggestions were made kind of clarification. One was why district ourselves to determine neoclassical assumptions. The reason was that we want to have an internal assessment, critique analysis of that. So keeping the assumptions same, what are the results we are getting? Of course, there is a case for external critique as well to take these assumptions and then see what happens. But the first two we wanted to do that, so that's the answer for this. As you made it very clear, for the internal critique, one can also see in terms of finding internal contradictions, whether there is any contradiction between what they are saying and what is the follow-up in terms of distribution. That's first point. Second is why we are using CSV data, not SAS. The reason being that SAS there is a time gap to institutional survey, quite a time gap, and then they don't repeat the same farmers. CSCP, we were restricted ourselves to 3 years, because for these 3 years they were repeating the same farmers and trying to take the data. So that was the reason we would actually understand their cost function much better, because the same farmer is being followed from here. And then the last one was what the elasticity of substitution or not. This is the cost price elasticity of substitution, whereby we are just showing that it is more than one for this human animal labor and human labor. These are the machine fuel, which is not so much, because I think there is some confusion here. This cost price elasticity is basically percentage change in the usage of machine fuel, how much we are substituting, or the percentage change in the price. So it's not very high. In fact, it should be 10, 100. Then it is considered to be having so much of a substitution. It is definitely a strong substitution, but nevertheless not so much. So
Thank
these are the three.
Thank you, Aparajay. Ashish, anything you would like to say? Quick, please.
Yeah, we can make a critical framework, probably it will be utility-based framework. And on the sampling design, yes, we did a multi-stage sampling. So in the final stage of selection of village and number of farmers, so we selected farmers randomly. We did not follow any listing or any such method. We simply went to different farmers' house and collected the data for approximately around 50 farmers from each village, out of which some were adopters, some were non-adopters. So we did not follow any specific listing kind of and selecting some as such. Yes, and yeah, the relationship between credit and insurance, yeah, it's a debatable thing, and there is an issue of endogeneity there for sure. But we have not taken it as an endogenous variable in our model. And for description of data, yes, I had a slide on discussion on sampling design as well as the descriptive statistics, but I did not show it because when I was trying to open it on the laptop, it was not coming out properly. So that's why I skipped that slide completely, which had descriptive statistics as well as results as well as with potential relationship between those variables. So maybe that's why some of the things were not explained properly. And while the question on claim settlement, so often in KMWI the major challenges are in terms of claim settlement and the time they take to settle those claims as well as the amount of claims. So when I was conducting the survey, it was the month of November to February. So the claim settlement do not happen immediately. Sometimes they are often delayed. So at that time I did not collect any data on what claims they were about to receive. So I do not have that information, but I have collected the information on have they received any claims in last 2-3 years, because many of the times the claim settlement process is time taking, especially in context of the crop insurance scheme we are operating on right now. So yes, there is a major hurdle in terms of adoption, in terms of the payouts they receive, the amount they are getting. Often it has been criticized on the ground that the amount they receive is very small, right? It is not much of use to them in cultivation and purchase of inputs. Also, there are other ways in terms of since the premium is now determined actually, and only a section of it is paid by farmers. Though it's only a small portion, or 2% for Kharif and 1.5 for Rabi, still it's a big amount for farmers, and since the last few years the premium has been increasing. So they find it hard to purchase the insurance, especially given the fact that the chances of payout are again small. Yes, it's a major hurdle to that. I agree to it, and I think the policy has to look into this as well, that why farmers do. If many of the farmers previously they were purchasing insurance because it was bundled with credit, but since 2020 this has been dismantled, and it's a voluntary thing now that farmers can purchase insurance if they want to. And in my area of the study, but this has shown a consistent decline in farmers adopting for crop insurance. So it could be one of the reasons that since AP has a very high number of credit card users, Kisan credit card users. So since now these are segregated, so it is one of the reasons why the adoption rate has gone down there as well.
Should give a round of applause to the presenters, doctors, and the discussion and the participants.